Hey, this is Rodham here, and we're gonna take a look at a medium level difficulty question this time on reverse integer. So, given a signed 32-bit integer x, return x with its digit reversed, and if reversing x causes a value to go outside the 32-bit integer range, so you can see it's a negative 2 to the power 31 or 2 to the power 31 minus 1, then return 0. Yeah, so let's just take a look at this so we can first, let's address the integer bit here. So if reverse is greater or equal to 2 to the power of 31 minus 1 as it shows in the example, or reverse is less. And I haven't come up with a definition of reverse yet, but that's just going to be the total is less or equal to 2 to the power negative 2 to the power 31, and we just return 0. Otherwise, we're going to return reverse. And we haven't really defined reverse yet, but we will. So how should we go on about this here? So we can do this, I think, just with one iteration. We can't. I assume we can't use like a reversed function here. So otherwise, I think an easier way could just be make a list or turn this into a list of like a string list, and then reverse it, and then return the reverse, right? And then if there's a negative that we can get kind of rid of it. We're gonna do something relatively similar, but I don't want to make a list to take up too much space, because once we make a list, we're gonna take up all of n space here. So first, I think we should come up with a basic formula here. So we have reverse at 0, so this is going to be the space that we take up, which is going to be constant. So what we want to do, I think a good trick to do this is using the modulus operator. So if we have the value of x, for example, we can get like the last digit with a modulus operator. So for example, if I have 312 modulus 10, whoops, 10, it's going to equal 2, right? And then after that, we plug it into the reverse, and then what we're going to do is divide floor division this by 10, so it's going to equal 331, right? And then we're going to do the same thing. We're going to 31 modulus, and then it's going to be 1, and then every time we do this, we're going to multiply by 10 and then add the last digit. And then we're going to do the same thing. 1 modulus 10 is just going to be, I forgot what digit I put in. Oh, sorry, it was 3, right? 3 modulus 10. It's going to be 3, and right, it's going to be reversed, and then we're going to come out of the loop. So how do we do this here? First, we got to account for negative. So in example 2, we see input x can be a negative factor here, or negative integer here. So when you actually modulus 10 a negative integer, you get something completely different, just because of how the modulus operator works. And to do this, I think you can go on about this multiple ways, but I would just say, just to check the status of negative, negative is going to be true if x is greater or less than 0, else false, right? And if negative, we're going to x multiply by negative x, negative 1. There you go. So we're going to turn it to positive, and we're going to account for this, right? So return reverse if not negative, else reverse multiply. So we're just going to return, if it was negative, we're going to revert it back to negative here, because we're going to change it here. So let's come up with the main bread and butter of the function. So we haven't even defined reverse yet, but this is going to be the reversed integer, if you couldn't tell already. So let's do an iteration here. So let's do a while loop here. So while x. So if x does not equal 0, and it'll eventually get to 0, as you saw in the example, when we do floor division, it's eventually going to hit 0 here. So let's take a look, and we're going to need to iterate through the, or while we're iterating, we're gonna have to do the modulus operator. So to keep the track, so let's call it val here. It's gonna be x modulus 10. So that's gonna get us the last digit, and then we have to get rid of the last digit by doing the floor division of 10. So, and then reverse is going to just be the reverse, right? Remember, we have to multiply by 10. The first digit, it's not going to matter because, you know, it's at 0. 0 times 10 is going to be, whoops, 0. And then we're going to add the val, right? And this should be pretty much all the logic here, right? Because the first time, times 10, going to do nothing. So, for example, if we had the number, let's look at the first example here, 1, 2, 3. The first time we're going to get 3 from the value, and x is going to get turned to 12, and then the reverse times 10 plus 3 is going to be 3, and then we're going to go through that again, so we're going to get 2 as the value here, and then we're going to do floor division again, so we're going to be left with 1, and then we're going to multiply this by 10, and then add 2. And then we're going to do that one last time, and it's going to reverse the number, right? So as long as that's clear, and now this is just kind of an edge case that the question told us to check, that we put it right in the beginning, and then we just returned the reverse value, right? As we saw, it was going to be 321, and if it was negative, we just add the negative right back. So hopefully this runs just a-okay. Yeah, so there you go. That should work. And as for the time complexity here, it's just going to be O of n time. We're only iterating through pretty much once, right? It says while x, but we're just iterating through the length of the integer, right? So when it was 123 on x, we only iterated through it 3 times, just because each time we're doing the floor division 10 operator, so it's shrinking by 1 length every time. And then the rest is pretty constant in terms of operation. You're going to do that regardless, and it's going to be the O1 space, because we are not making a list or anything. We're not taking up any space. We're just returning the correct number. Okay, perfect. Hopefully this helped. Thank you so much.